This is a lesson for 15-3. What you're doing today is graphing absolute value functions and seeing how they change, all right? We already covered a little bit about this before with parabolas and things like that. Today, we are using just absolute value functions. So first of all, how do you graph an absolute value function on the calculator, all right? The absolute value function, all right, we're going to graph this function right here. Y equals the absolute value of X. Now, there is no absolute value button on the calculator. So whenever you see these two straight up and down lines, that's the symbol for absolute value. So the way that you get the absolute value on the calculator, you have to hit the second button first, right? You have to hit the second button first, and then you have to go into the catalog. All right, so second button, catalog. Catalog is the 0 key. When you hit the 0 key, the absolute value is the first thing that pops up. It's the ABS, that stands for absolute value. So hit second, catalog, which is second and 0. And then notice how this is on the ABS already. If we wanted something different, we could just use the arrow pad to move it. But we want the absolute value, so then you're just going to hit enter in that bottom right-hand corner. Notice how it puts the absolute value symbols right there. And you just have to type in whatever you want to. So we're going to type in the absolute value of X. Now, you're going to be graphing a bunch of different kinds of absolute value functions today. Sometimes you're going to be adding or subtracting a number just to the X. If we wanted to type it or add it just to the X, then we have to make sure that we're typing inside the absolute value symbol. But we're also going to be adding or subtracting to the entire function. If we did it to the entire function, to get outside of the absolute value symbol, you have to use the arrow pad and go to the right. All right. When I hit that arrow pad to the right, notice how my cursor jumped to the outside of there. Now I can type on the outside of the absolute value. So you just have to use that cursor and tab over out to the right. All right. So we're going to graph the absolute value of X. This is the absolute value of X. I tried to save us some time by putting the graphs on the notes already. Those of you in person, you can see those already. So I'm actually going to close out the calculator here. And hopefully my screen shares and goes big. I'm just going to share it again just to make sure, double check. All right, so what's called a parent function. The parent function is the original equation, all right? The parent function is the original equation. We're comparing all of these to this absolute value function, all right? So this is the absolute value of X. When you type that into your Y equals, this is what the graph looks like, all right? It has, where it says has a, does this absolute value function have a min or does it have a max? A min. Min is at the bottom. So it has a min, all right? Max would be like the capital letter A, all right? What is the y-intercept? Where does the line cross the y-axis, all right? Where does it cross the y-axis? It crosses it at the point right here. That point is 0, 0. Where does it cross the x-axis? So now we're looking at this axis. Where does it cross or touch the x-axis? Well, it happens to touch it at the same exact place. It is at 0, 0. Domain and range. Please remember, this is very important as we start getting closer and closer to the Regents exam. Domain means X, range means Y. Remember that they are in alphabetical order. Domain and range are in alphabetical order. Domain means X, range means Y. So what is the domain of the graph? What are your X values of the graph? Now, the other day, we had like X values in between 0 and 5 or things like that. And we used less than and less than or equal to symbols. Notice that this graph doesn't have any of those restrictions. It keeps on going and going and going to the left. It keeps on going and going and going to the right. If we zoomed out, it would just keep on going and going and going. So the domain or your x values of the graph are all real x values. All the real x values. Your range is your y values. So what are the y values of the graph? Well, your y, the lowest point of the graph is the min, which is right on the x-axis. So that right on the x-axis is 0. So it is y is greater than or equal to 0, because it includes all of these values that are all greater than or equal to 0. We don't have any negative values there for y. Therefore, it's all the values that are equal to 0 or greater than 0. So it's y is greater than or equal to 0. So that's the original one that we're looking at. If we go to do a translation, I have to think back to when we did this. A translation slides a picture, right? A translation slides a picture. It moves it to the left, it moves it to the right, it moves it up, it moves it down. It just takes it from one place on the graph to a different place on the graph. It just slides it, right? It just slides it from one place to another place. By adding or subtracting a number to the entire function, it slides it up or down. By adding or subtracting a number to the entire function, it makes it go up or makes it go down. So this was our original one. All right, we already know the answers to this one. This was our original one that we just did on the previous slide. So I'm just going to refill these in just so that we can compare them a little bit easier. So when we take a look at this middle one, in this middle one, notice that we are adding 2 to the entire graph. All right, we're adding 2 to the entire function. That's different than in what the next one's going to be, where we're going to add 2 just to the x. Notice that this plus 2 is inside the absolute value. It's being added just to the x, where this one that we're doing is being added to the entire function. All right, so this is being added to the entire function. If we're adding, we're going to go up. Look at what happened to our graph from the first one to the second one. All that happened to our v for our absolute value is that it moved up. We added by 2, so the min, the point of the v, went up by 2. Anytime that we add something to the entire function, the graph is going to slide up. So this graph still has a min. The graph is a translation of up to. It is a translation up to. The y-intercept, where the line crosses the y-axis. Where does it cross the y-axis? It crosses it at 0, 2. Where does it cross the x-axis? All right, here's your x-axis. Where does it cross the x-axis? It doesn't, so it does not have one. Your domain of your graph. We go forever to the left. We go forever to the right. So all the positive numbers, all the negative numbers. So it is all real x. The range of our graph, 2 is the lowest number right there for our y values. But everything above it is in our graph. So the range is y is greater than or equal to 2. If we subtract 3 from the entire function, if we subtract 3 to the entire function, notice what happened from our original one here in the blue to the one in the black. Notice that all that happened was it slid down. So it still has a min. The graph is a translation of down 3, because we're subtracting by 3. The y-intercept, where the line crosses the y-axis. It crosses it right at this point. That point is 0, -3. Where does it cross the x-axis? Now, this is a little bit weird because it crosses it at 2 places. It crosses it right here, and it crosses right here. So it has 2 x-intercepts. They are -3, 0 and 3, 0, because they cross it at 2 different places. The domain, we're still going all the numbers to the left, all the numbers to the right, so it is all real x values. The range, we have everything from -3 on up. So y is greater than or equal to -3. So those were our translations going up or down. That is when you add or subtract the number to the entire function. If we just add or subtract a number to the x, all right, if we just add or subtract the number to the x, so inside the absolute value symbol, that's when it's going to shift or slide to the left or right. So again, this was our original one, all right? This was our original one that we looked at. Let's just take a look at the middle column. You've already written this twice. So looking at the middle one, the red one, it has does it have a min or a max? It has a min still. The graph is a translation. And notice that we're sliding to the left. So we're going left 2. The y-intercept, where the line crosses the y-axis, is right there at 0, 2. The x-intercept, where it crosses or touches the x-axis, is right here. That point is over to -2, up to 0. The domain, our graph goes forever to the left. It goes forever to the right. So it is all real x. And the range is everything from 0 on up. So y is greater than or equal to 0. Shifting something to the right or sliding something to the right, we are going to subtract just from the x value. The nice thing about these questions is you really don't need to memorize this, because you can always just go on your calculator and graph it and see what it did, what movement it made. So this has a min. The graph is a translation of right 3. We slid it 3 places to the right. The y-intercept is where the line crosses the y-axis. It crosses it right here at 0, 3. The x-intercept is where it touches or crosses the x-axis. That is at 3, 0. The domain, it goes forever to the left. It goes forever to the right. So it is all real x. And the range, your y values, the bottom is 0, and we have all the numbers that are up above it. So that is y is greater than or equal to 0. So those were your translations, right? Those were your translations. The next type are reflections. What makes a reflection, remember, a reflection is that mirror opposite image. What makes a reflection is a negative sign outside of the absolute value symbol. So notice that we have a negative sign right here, a negative sign right here, a negative sign right here. Those are all going to flip your graph upside down. So this has a max this time. All right, this has a max as compared to the as compared to the original parent function of just the absolute value of x. The graph is a reflection. It's a reflection over the x-axis. The y-intercept, where the line crosses the y-axis, is right there in the middle at 0, 0. Where it crosses the x-axis is the same exact point, 0, 0. The domain, your x values, it goes on forever in both directions, so it's all real x. The range, when you take a look at your graph, all of our values are from 0 down. So it is y is less than or equal to 0. Before we had greater than or equal to 0 because our graph was up above. Now we have less than or equal to 0 because it's down below. Now, those are all ones that just had one movement. These next two have two different things going on, and you will have questions on your homework like this today. So first of all, this has a max because it has that mountain. It has that tip of the A. Now, the graph is, there's two different things going on here. The first thing that I see, because of the negative sign, is a reflection over the x-axis. But we're also subtracting just the x by 3. If we subtract just the x by 3, that means we also have a translation of right 3. So there's two different things going on here because of the negative sign outside and the -3 inside. Our y-intercept, where the line crosses the y-axis, that is at 0, -3. The x-axis, it touches it right here. That is at 3, 0. The domain, our graph goes on and on and on forever in both directions, left and right. So it's all the real x values. And our range, everything is at 0 or below. So this is y is less than or equal to 0. For the third one, we have two different things going on as well. We have a negative sign outside, but then we're adding 2 to the entire thing, to the entire function. This has a max. The graph is a reflection over the x-axis. Reflection over the x-axis. It's also, because of the +2 to the entire thing, notice that it shifted or slid up. So it's a translation also of up 2. Translation of up 2. The y-intercept, where it crosses the y-axis, is right here at 0, 2. The x-intercept, it actually has 2 of them, here and here, where it crosses the x-axis. So -2, 0 and 2, 0. The domain, it goes on and on forever in both directions. So it's all real x. The range is your y values. That includes everything that is down below 2. So y is less than or equal to 2. So again, your reflection flips it. All right, the translation slide it in one of the directions. The reflection flips it upside down. The last type, and this is the last slide, the last type is a dilation. Dilations make it skinnier or wider. If you don't want to say narrower, I don't really like narrower. I like skinnier. So skinnier or narrower, all right, by multiplying by a number out in front. All right, we're multiplying by a number out in front. If you're multiplying by a fraction, it's going to get wider. If you're multiplying by a fraction, it's going to get wider. If you're multiplying by a number that is bigger than 1, it's going to get skinnier. This is just our original one over here. All right, this is just our original one. Notice that what we did here is we multiplied by 4. Here we're multiplying by 1/2. Notice how it took our original one, and because we multiplied the whole thing by 4, it got skinnier. So this one has a min. The graph is a dilation. A dilation makes it wider or skinnier. So it is a dilation where we get skinnier, or you could say narrower. The y-intercept, where it touches the y-axis, crosses the y-axis, is 0, 0. The x-axis is the same thing, 0, 0. Domain, it goes on forever in both directions. So it's all real x. The range, it is everything from 0 on up. So y is greater than or equal to 0. And the last one. Notice how this one gets wider as compared to our original one. So this one has a min. The graph is a dilation that is wider because we're multiplying by 1/2. The y-intercept is 0, 0. X-intercept, 0, 0. The domain, it goes on forever in both directions. Yes, we did write all real x for every single one. And the range is everything above 0. So the easiest way, you really don't need to memorize these. The safest way, especially when it gets to your Regents exam, the safest way is just to type them into the calculator. All right, type them into the calculator and see what the graph looks like.